Well, I taught my 21st successive geology field camp this 40 students. This is the group from a couple of years ago standing high up in the Raft River Range, about 7,500 feet, and beyond them is an exquisite fold that they get to map, created actually by Miocene extension. I also teach geology at Utah since Ron Brune retired 7 years ago, which I have cunningly reinvented as a de facto prerequisite for the capstone sequence. I teach a section of living with earthquakes and volcanoes every year, and I also taught the inaugural installment of the new Wasatch in the field. For about the same length of time that I've been teaching that course, I've been studying paleoseismology of faults submerged beneath Utah Lake and beneath the Great Salt Lake. These green faults all rupture in direct relationship to ruptures in the Provo segment. So they're auxiliary faults, just like the West Valley faults are to the Salt Lake City segment. There are some nasty things out in Utah Lake. Everything in pink here, well, the two large ones in the north and the east there, those are two massive debris flows. This one was 17 meters thick when it reached the lake, having crossed American Fork. And this shows that we can also get event horizons out of this data. It turns out that there are the equivalent of colluvial wedges associated with many of the events. It turns out that the entire bottom of the lake liquefies periodically, and this is just the uppermost of a stack of these earthquake-triggered debris flows that cut across the valley. And it turns out that even auxiliary faults have auxiliary faults that help in defining the event horizons. That was the map for Utah Lake. That's the most recent one, but we did the same thing, Jim Peschman and I, for the Great Salt Lake, the same type of data where we were able to accurately locate and identify event horizons on the Antelope segment, the Fremont segment, the Promontory segment, and the Carrington Fault. There's further northerly segment up, we call the Roselle segment up to the north, and we cored those event horizons on the Fremont and Antelope segments and dated them using radiocarbon techniques. So we were able to establish the recurrence interval of surface rupturing earthquakes on those segments that way. Thanks.